In the last one there, we took a look at translations of functions where we were transformations of functions where we were changing the a value, flipping it upside down, stretching and compressing it. Here we're going to take a look at affecting the position of the graph left and right, up, down. And so we're going to do that using these letters H and K. So if we compare to our standard quadratic function again, and that's going to again be our base, x squared. So here, note last section I was using y equals x squared. Here I'm using f of x equals x squared. Again, remember, these are interchangeable concepts in terms of being a function. We can use the y to replace f of x, and they both will be used interchangeably throughout the course when we're talking about functions only. But we have our function, quadratic function there, standard one, x squared, and we're going to use this concept of having in the brackets with the x, so before the x is squared, we're going to subtract an h value, and then after we've squared it, we add a k value, and those are going to cause the graph to shift left, right in terms of the h, and the k is going to make it go up, down. Something important to note is, notice that we do use a negative sign in the brackets here. This is a positive one, this is a negative one. Is there a special reason why that's negative? Yes, there is. The negative sign is there because it does everything, makes everything opposite. So if you have the situation where the sign is negative, so we have x minus 4 squared, then when we look at the actual h value itself, h is actually equal to 4. But if we have, in this case here, we're using function dt. If the h value is plus 2 in here, so the value is plus 2 in here, the actual h value is negative 2. The h value is always the opposite sign of what is in the brackets. Okay, that's important to remember. Anytime we're working with quadratics and different functions and we have this sign in the brackets, it's going to always work in the opposite way than we normally think. So let's take a look at how this works. We're going to start with the h, and h causes horizontal translations, and it's nice that h is for horizontal, going left, right. Unfortunately, k, I don't know why k goes up, down instead of v or something. But the h is going to cause left, right motion. If we take a look at a couple examples here, we got a negative h, a negative 3 in here, so that means that h is actually equal to 3. If we graph this, what this does is it's going to shift all the points to the right. So everything's going to go to the right, to the positive side. And again, if we make a quick little table of values here for x squared, then we have 0, and I'll just do 0, 1, 2, 3 in this case, and the y. So our standard graph that I have here is going to be 0, 1, 4, 9. But if we take that x minus 3 squared, then what we have is now 0, 1, 2, 3, and I'm kind of squeezing this in. But 0 minus 3 is going to be negative 3, so that's going to be 9. That's going to be 4. That's going to be 1, and that's going to be 0. And if you take a look here, those would be the preceding ones, the negative 1, the negative 2, the negative 3 kind of thing. It's kind of going, it's all shifted backwards. So what ends up happening here if we graph these, so 0's up at 9, 1's at 4, 2 is at 1, 3 is at 0, and you see we have this half the parabola. Basically, each of these points has been shifted to the right. And so if we continue that same pattern, shift this over 3, shift this over 3, and shift this one over 3, what we get is this parabola over here. So everything's just been shifted over 3. The negative 3 means h is 3, so everything shifts to positive 3, or shifts by positive 3. The opposite works when it's a positive number. So in this case, our h value would be negative 2. So everything's just going to shift to the left. It's going to go back 2. So if I take each of these points and I slide them back 2, that one overlaps, by the way. Shift them all back 2. And there we have our shifted graph. Little terrible of a parabola, not very curvy, but we've shifted it all back. So if we got a negative value here, it shifts every point over by that value. Here it shifts every point back by that value. So positive h goes to the right, negative h goes to the left. If we flip the page here, now we'll look at the k value. So the k value is not in the brackets. So the k value does exactly what it looks like it should. And it just shifts our points up and down. This should be up. And again, we'll take a quick look. X, Y, 0, 1, 2, 3. And this will be our x squared again. So that's just 0, 1, 4, 9. There's our standard graph. Now if we take these, and in this case we're just adding 2 to them each time. So x squared plus 2 is going to give us x, 0, 1, 2, 3. And y, we're just going to add 2 to each of these. So 2, 3, 4, or sorry, 2 to the squared numbers. 2, 3, 6, and 11. So now we've just shifted each of those points up. So if we take 0 and 2, 1 and 3, 2 and, oh, so we're going up 2. Going up 3 there. 2 and 6, and 3 and 11. So you see each point just got shifted up 2 points. So if we shift the rest of these up to mirror this off, we have our shifted parabola. Exact same shape, it just happens to be pushed up. So it kind of looks like it was compressed, but that's just the fact that we're working in limited space. We've picked it up and moved it all up too. So the opposite happens here. When it's a negative value, it's just going to shift down that much. So each point is going to go down 3. So we could quickly graph this one by taking our base and shifting each point down 3. And connect the dots. And again, we have the same graph, just everything's been picked up and moved down 3. So the same shape of graph in each case. Negative moves it down, positive moves it up. Again, the difference was when it was in the brackets. Here with the h, when it was in the brackets with the h, that's when h is opposite as to what's in the brackets. K is not in the brackets, so k just does its normal thing. Now, also important to note in all these cases, and when we combine it all together, the vertex of the parabola is just going to be the hk value. So you notice here, there's a 0. If we were to put the x in brackets here, what can we add or subtract to x and not change it? Well, we could add or subtract 0. So 0 and 2, 0 and 2, there's our vertex. Here, 0 and negative 3, there's our vertex. So these hk values, they represent the vertex. Same idea over here, positive 2 plus 0. So that means negative 2 here, so negative 2 and 0. And so the hk value, that's the vertex of the parabola, just by looking at that equation. So there you have your different transformations using the HK translations.